Good afternoon, children. First of all, I would like to congratulate for your second PC theory result. Now you need to concentrate much on competitive exam. Okay, let us start today's topic. Ethers and carboxylic acid, the exam which have appeared in the morning, this one hours. Now we are going to discuss the paper on ethers and carboxylic acids. We'll go to the question one by one. Okay. Question number 1. The major product during hydroboration oxidation of 1-methyl cyclopentene. What is 1-methyl cyclopentene? Tell me. 1-methyl cyclopentene. This is 1-methyl cyclopentene. 1-methyl cyclopentene. When 1-methyl cyclopentene undergoes addition with boron, that is, they are saying that hydroboration oxidation will be by adding B2H6 in presence of H2O2 and alkaline. Always remember that this will follow anti-Markovnikov's rule. What it will follow, children? Anti-Markovnikov's rule. It will follow what? Anti-Markovnikov's rule. Anti-Markovnikov's rule. That's why we can say that whenever we are going to add like this molecule, we'll get a water cyclopentene. We'll get the same cyclopentene over here, the double bond, because we are going to add in presence of B2H6 and as well as water, but that is basic medium. We are going to get the product on the basis of this one as methyl and alcohol. The option is water, fourth one. Option is water, fourth one. We are going to simple way. Actually, the children, simple way is instead of adding diborane, because diborane addition will take time. That's why instead of diborane, directly we can add water. But remember here, you have to follow anti-Markovnikov's rule. Therefore, the product is water, fourth option. Next one. Second question. 2-propanol with sodium bromide. What? 2-propanol with sodium bromide. What happened? When the propanol is added, because we are going to reflux. Okay? CH3, CH, OH, CH3. That is 2-propanol by refluxing with the sodium bromide. OH group is replaced by what? Br. That is 2-bromopropane. First option. Next, third question. Primary amine on treatment with NaNO2. We know very well that primary amine they are saying. But you need to remember that maybe aliphatic, maybe aromatic, they have not mentioned. But with respect to the option, we can come to know that this will be aliphatic. Therefore, when primary aliphatic amine treated with nitrous acid, because NaNO2 and HCl are going to produce what, children? HNO2, that is nitrous acid, will produce primary alcohol. Will produce what? Primary alcohol. One more point you may be remembering that whenever we are going to take the aromatic, we are going to get the product as diazonium salt. But that diazonium salt is not possible for primary aliphatic amine. Next question. Next question. Next question, question number 4. Question number 4. Hydroboration oxidation of 4-methyl octene. What they said? 4-methyl octene. We will write the structure CH3, CH2, 3 times. It will become butane, then CH, CH3, CH2, then CH, double bond CH2. 1, 2, 3, 4. 4-methyl octene. When they are treated with the addition of diborane, again the same question arises with respect to anti-Markovnikov's rule. So here we can say that whenever we are going to add, it should be added in such a way that, as I said earlier, first question, that simple way to add H2O and follows anti-Markovnikov's rule. Don't go for writing lengthy answer, because we need to consume less time also. That's why we can say that when we are going to get this one, we'll get the product as 4-methyl octanol. We'll get the product as what, children? 4-methyl octanol, because the negative part will be added to the carbon containing more number of hydrogen atom. Next, question number 5. By which of the following procedure we can get normal propyl ether? Normal propyl ether can be obtained. By which of the reaction they are asking? Always remember that to get a normal propyl ether, and it should be what? Alkyl halide. Whatever the alkyl halide are there, it should be what? It should be primary. Therefore, the correct option is what? Question number 5. Option will be second. If I am going to write ethyl alcohol with hydrogen bromide will produce ethyl bromide, with magnesium and ether will produce ethyl magnesium bromide. Okay. Further with formaldehyde, CH2O is nothing but what, children? So that is formaldehyde. Will get the propanol, that is CH3, CH2, CH2OH. Propanol. Further, when treated with sodium metal, here OH is replaced by ONA. OH is replaced by what, children? ONA. OH is replaced by ONA, that is CH3, CH2, CH2, ONA. Sodium propoxide. When treated with ethyl bromide, we are going to get ethyl normal propyl ether. Therefore, the correct option is what? Second option. Next one. Question number 6. When benzene treated with the sulfuric acid, okay, benzene reflux with alkali. Have you remembered what we are going to get, children? We are going to get reflux, because it is electrophilic substitution reaction to get benzene sulfonic acid. Further, they said fused with alkali. They are going to heat it. We are going to get the product as phenol. And we know very well that this phenol, when undergoes bromination in presence of water, we are going to get 2,4,6-tribromophenol. Option number 4th. Okay, option number 4th. Next question. Which of the following reaction will not yield para-tertiary butyl phenol? Para-tertiary butyl phenol. So how it should be? Like this. This is phenol. It should be para-tertiary butyl. Like this. Like this. Para-tertiary butyl phenol. Remember one thing, whenever we are going to treat phenol with this one, we'll get the same product, this also. But this is Reamer-Tiemann reaction. What happened during this? This is a Reamer-Tiemann reaction where we are going to get the product as salicyl aldehyde, OH and CHO. We are going to get the product as what? Salicyl aldehyde. Therefore, then we cannot prepare para-tertiary butyl phenol by 4th option. Next one. Acetic acid is obtained from ethyl alcohol by the process of what? Fermentation. Acetic acid is obtained from ethyl alcohol by which method? By fermentation method. It is a theoretical based question. When diethyl ether is heated, diethyl ether, okay, it is going to be heated with for excess of PCl5. Excess of PCl5. So what will get? Ethyl chloride. We'll get the mixture of ethyl chloride and ethyl chloride only, because with limited supply, we are going to get what? Ethyl alcohol and ethyl chloride. But with excess, we are going to get what? Completely ethyl chloride only. Therefore, which is the option? First option. Next question. To prepare, question number 10, what is that? To prepare, we are going to get a tertiary alcohol. It is one side is phenyl. This represent what, children? Phenyl. Okay. This will be phenyl. It is like a benzyl derivatives over here. OH group is present over here. Which is the incorrect pair they are asking. When they are to prepare this one, which is the incorrect pair. RMGX with this, that is a ketone, 100% it is going to prepare the same. This also going to prepare the same, but will not get with respect to this. Why, tell me? Look at here. C2H5COMGBr. Okay. This will be what? CH3, and this side we are going to get phenyl group. Okay. Then we know very well that this on further conversion, that is with the elimination of MgBr, they are converted into what? We are going to get what? Tertiary. That is ketone. C2H5 C double bond O. We are going to get what? C double bond O CH3. And this further treated with Grignard reagent. This further treated with Grignard reagent, that is RMGX. We are going to get C2H5COH, CH3 and R. But actually we are going to prepare what? Both the side ethyl. That's why we cannot prepare by which option? Fourth option. Which alcohol is most acidic? Question number 11 they have asked, which alcohol is more acidic? We know the acidic nature of alcohol as with respect to what? Primary greater than secondary than tertiary alcohol. Correct? Primary, secondary and tertiary alcohol. Before primary we can write it as methyl alcohol. Therefore the correct answer is what? Methanol. Question number 12. Alcohol. This is a kind of which alcohol, children? Primary alcohol. What? This is a primary alcohol. The nature of this alcohol is what? Primary alcohol. That's why we can say that this cannot be obtained, they are saying. Remember one thing, formaldehyde with Grignard reagent will produce primary alcohol. Even epoxide with Grignard reagent also produces primary alcohol. But what they said over here, this one magnesium halide with oxygen, they are converted into alkoxide. Further on hydrolysis, again it will also give primary alcohol. But aldehyde other than formaldehyde with Grignard reagent produces secondary alcohol. Remember one thing, children, only by writing the long reaction, don't think that we are going to get the correct answer, and we cannot manage time also. That's why better what I suggest to you, that better to go with the this one based upon the clues only, just to go for answering the question. Because as we said that formaldehyde with Grignard reagent gives primary alcohol. Same way epoxide with Grignard reagent also gives primary alcohol. This COMGX will get. This on further hydrolysis converted into COH. And already it has 2 hydrogen atoms. So it means that this is also primary. But they are asking what? Which cannot be prepared. Therefore the answer is what? Fourth option. Why the fourth option? Because fourth option is suitable to prepare secondary alcohol. Fourth option is suitable to prepare what, children? Secondary alcohol. Next question. Isobutyl alcohol. What is isobutyl alcohol? This is isobutyl alcohol. When isobutyl alcohol treated with phosphorus and iodine, they are going to replace OH group by OH group by NO2, and they are going to produce nitroso compound. That means that it comes under which test? Tell me. Victor Meyer's test. Victor Mayer's test, which is also called as RBW, red, blue, and white. And here the alcohol is a type of which one? We are going to get the Victor Mayer's test. What they are saying that the true statement, the true statement about the compound A is. They are asking that which will be the true statement with respect to the compound A. That's why we can say that it will be red color solution, because this is a type of primary. Primary alcohol will give red color, secondary alcohol will give blue color, and tertiary will give colorless. Wait, tertiary alcohol will get which color? Colorless. That is white, colorless. That's why we are going to write with respect to this one. Next question. Next question. Question number 14. Which of the following is a gas? Methane thiol, ethane thiol, isobutyl thiol, and propyl thiol. Remember one thing, whenever we are going to write the thiol, OH alcohol is replaced by SH. SH. That's why we know very well that methane thiol, CH3SH, lowest one will be what? Gaseous in nature. Lowest one will be what, children? Gaseous, this one. Okay. Next one. Next what? Question number 15. What we said? Which of the following is the best method to prepare isopropyl methyl ether? Better to write first structure. This is isopropyl and this is methyl ether. Isopropyl methyl ether they are asking. Remember one thing, to prepare isopropyl methyl ether over here, they have given the different this one. Like the methyl iodide they have given over here. This is a water, this one based upon the CHOH. So we can say that whenever we are going to write with respect, this will be CHOH. Okay, it should be water, second option. It should be water, second option. Next one. When benzene sulfonic acid and paranitrophenol, what is benzene sulfonic acid? SO3H. It is acidic in nature. Same way, water, paranitrophenol also. Paranitrophenol. When both are treated with the sodium bicarbonate solution, both are acidic, the gas liberated will be only carbon dioxide. Therefore, the correct option is fourth one. Only carbon dioxide gas is going to be liberated. Question number 17. 3-methyl-2-butanol. What? 2-butanol. This is 3-methyl. On treatment with HCl, always remember that they will follow the carbocation which is more stable. And the order of this one, with respect to the carbocation, order of stability will be tertiary, secondary, primary, and methyl. That's why we can say that whenever they are going to get, this will be hydrogen. Okay, this will be hydrogen. Whenever they are going to get the carbocation over here, it will be kind of secondary. That's why by hydride shifting, they are converted into tertiary. We'll get like this. Okay, CH2, CH3. Okay, with this, there is an attack of OH minus. What happened on this? There is an attack of OH minus. When OH minus attack over here, what we can say with respect to water, we are going to get it as 2-methyl butane. Therefore, the option is water, first one. Remember one thing. You'll get all the college toppers and all the percentage and all. By tomorrow, you'll get in newspaper. Even we will post on WhatsApp. Okay, now we are discussing the paper. Better that we'll concentrate on paper. Okay, next. The product A is what they are asking. The product A. Remember here, it is a water. What it is with respect to metahydroxybenzyl alcohol. No question of sorry and all. Concentrate on paper. So here metahydroxybenzyl alcohol. Therefore, when they are treated with this one, that is a potassium carbonate. Remember one thing, phenols are acidic in nature. That's why we are going to get it as what? OK. And this will be CH2OH. This will be what, children? CH2OH. We know very well that with methyl iodide, means it is a type of water, Williamson's reaction. OCH3, and this will be CH2OH. Therefore, the correct option is what? Second option. The alcohol which is manufactured from water gas, they are saying it is a methyl alcohol. Water gas, that is the mixture of carbon monoxide and hydrogen. Carbon monoxide and hydrogen, when they undergoes further reduction in presence of chromic oxide and zinc oxide, will produce water? Methyl alcohol. Will produce water? Methyl alcohol. Question number 20. The compound on dehydrogenation gives ketone. What is dehydrogenation, children? Whenever the secondary alcohol, removal of hydrogen gas by heating with copper at around 573 Kelvin will produce ketone. Will produce what, children? Ketone. That's why we can say that the answer is secondary alcohol. Answer is what? Secondary alcohol. The best reagent to convert pent 3 into all. Pent 3 into all. 1, 2, 3, 4, 5. Okay. Pent 1, 2, 3. Pent 3 in and the 2 all. Okay. Pent 3 into all converted into pent 3 into one, because it is a kind of water secondary alcohol. That's why we can say that PCC, pyridinium chlorochromate, is the best method, because other are converted into lower carboxylic acid. Question number 22. Which reagent is more effective to convert but to enal? This is CHO 1 and 2. But to enal converted into but to enol. Like this. Which is the best method they are asking? The best method is what, children? Based upon this one, sodium boron hydride. Even we can say that, even we can take lithium aluminum hydride also. Remember one thing, sodium boron hydride or the lithium, this one aluminum hydride will not affect what? Carbon-carbon double bond. That is olefinic carbon atom. They are not going to affect olefinic carbon atom. Next one. The dehydration of neopentenol, because neo means what? All the carbon atoms will be branched. That time neopentenol will eliminate water molecule. That's why we are going to get the alkene over here. On reduction, lithium aluminum hydride, on reduction of lithium aluminum hydride, this one. So the ketone will yield water, secondary alcohol. Will produce what, children? Secondary alcohol. Secondary alcohol. Next question. Next question. Question number 25. 25. Ethyl propanoate, CH3. CH2, COO, C2H5. Okay, ethyl propanoate on reduction. Remember one thing, esters on reduction converted into primary alcohol. They are converted into what, children? Primary alcohol. That's why we can say that whenever the ethyl propanoate, question number 25, whenever the ethyl propanoate undergoes reduction, we are going to get what? One side one alcohol, other side other alcohol. This is propyl alcohol. Another side is what we are going to get? Ethyl alcohol. So we are going to get propanol and ethanol. The correct option is what, children? Second option. Next one, question number 26. Fenton's reagent is, okay, it can be used as an oxidant. It is the mixture of hydrogen peroxide and ferrous sulfate. Hydrogen peroxide and ferrous sulfate are used as antioxidant under the name Fenton's reagent. Question number 27. 27. Which of the following does not react with the sodium metal? Remember one thing, sodium is a active metal. Are you getting any blur image? No, no? Okay. So here we can say that sodium metal, it is a active metal. It is a active metal. Remember one thing, alcohols, carboxylic acid and phenol. Correct? In all the cases we are going to get ONA. Hydrogen atom is replaced by sodium to liberate hydrogen gas. But it is not possible in dimethyl ether. So we can say that when ethers with the sodium metal, no reaction. No reaction. But in all the cases, in all these three cases, there is a liberation of hydrogen gas. Not only with the sodium, any active metal. Not only with the sodium, any active metal. When treated with what, children? When active metal treated with acidic compound containing active hydrogen atom, they are going to liberate water, hydrogen gas. Phenol, when it reacts first with concentrated sulfuric acid. When phenol reacts with concentrated sulfuric acid, we'll get it as water. Phenol substituted water, SO3H, that is para-hydroxybenzene sulfonic acid. Para-hydroxybenzene sulfonic acid, which on further, because we are going to treat it with concentrated nitric acid. Phenol is orthopara directing in nature. That's why we are going to get it as orthonitrophenol. Next. Picric acid is what? Picric acid is 2,4,6-trinitrophenol. Picric acid is what, children? 2,4,6-trinitrophenol. 2,4,6-trinitrophenol is called as picric acid. Called as what, children? Picric acid, 2,4,6-trinitrophenol. That is third option. We are going to write it as trinitrophenol. Okay. Even they have given syn also. That's why we can go with the question number 29. We can go directly with this also. Because they have given with respect to symmetric. That's why I have changed. So when phenyl magnesium bromide reacts with tertiary butanol, phenyl magnesium bromide with tertiary butanol. This is tertiary butanol. Okay? Tertiary butanol. Remember one thing, whenever the Grignard reagent treated with compound containing active hydrogen atom, it will produce respective hydrocarbon. Therefore, the product is what, children? Benzene. Product is what? Benzene. RMGX, here I'll write one reaction for your reference, children. RMGX treated with water, alcohol, amine or ammonia, carboxylic acid, etc., etc., etc. R dash and GX I have taken Grignard reagent because to differentiate, we'll get the product as R dash H. That means that any compound containing active hydrogen atom with the Grignard reagent produces respective hydrocarbon. Huh? Produces what, children? Respective hydrocarbon. Question number 31. The IUPAC name of, remember here, one side we are having carboxylic group, other side we are having aldehyde group. Have you remember that whenever it is a polyfunctional isomer, whenever the question comes with the polyfunctional, remember one thing, we can give the order preference in such a way that carboxylic acid, it is a suffix, whereas this one, HCO, when it is a suffix act, we can name it as al. When it is a prefix, because two functional group are there, we can call it as aldo. That's why we can write CH2 4 times 1, 2, 3, 4. Okay, COOH. This will be carbon atom number 1, 2, 3, 4, 5, and 6. Correct? Sixth carbon atom is aldo. Hexane 1 oic acid. Therefore, option is what, children? Fourth option. In steam distillation, question number 32. 32. In steam distillation, the vapor pressure of the volatile organic compound is, okay, vapor, because steam distillation, what we said, we are the compound which are going to be purified in such a way that without this one, the purification, as soon after heating, they are undergoing water, they are going to be this one decomposed. That's why it should be less than atmospheric pressure, because boiling point depends upon what? Atmospheric pressure. Which is useful for separating benzoic acid, question number 33, which is useful separating benzoic acid from a mixture of methyl benzoate. Remember one thing, benzoic acid, it is a carboxylic acid. Methyl benzoate is what, children? It is a ester. Methyl benzoate is what? Ester. Whenever we are going to take benzoic acid and the methyl benzoate, they are going to be differentiated by using sodium bicarbonate solution. Because when acid treated with the sodium bicarbonate solution, they are going to produce effervescence due to liberation of carbon dioxide. They are going to produce what, children? Effervescence due to liberation of carbon dioxide. Next. Question number 34. Question number 34. 34. What they said over here? When acetaldehyde treated with formaldehyde with dilute NaOH and heat. Remember one thing, what we can say with respect to this one, it is like a cross aldol condensation. Correct? It is like a what, children? Cross aldol condensation. If I am going to write it as CH, H, C double bond OH. Correct? C double bond OH. When they are treated with, in presence of dilute alkali, H, okay, this we can write it as OH, CH2, aldol type of the product, aldol type of the product. Heating, they said, that's why by heating, they are going to eliminate water molecule to get CH2, double bond CH, C double bond OH. Correct? Then it is an example of what I said, children. It is an example of cross aldol condensation. Further, what they said with hydrogen cyanide. With hydrogen cyanide, what happened? Addition reaction takes place across this. Concentrate how I am making this one. COH, H and Cl. Correct? Next. This on further acid hydrolysis. They said what? Further on acid hydrolysis. Further on acid hydrolysis, they are converted into carboxylic acid. OH, H, COOH. You know, they are converted into what? Further carboxylic acid. That's why we can say that question number 34, which amongst all the option is correct you see over here? The option is first one. Option is first one. Here we are coming across the two reaction. One is aldol condensation, another one is nucleophilic addition reaction. It is what? Nucleophilic addition reaction. And this is what? Aldol condensation. This is what? Aldol condensation, where one containing alpha hydrogen atom, one do not contain alpha hydrogen atom. Carbonyl compound can undergo, question number 35, carbonyl compound can undergo electrophilic addition reaction, nucleophilic addition reaction, both AME. It will undergo nucleophilic addition reaction. Just now we have taken the example. That is, when aldehyde treated with hydrogen cyanide, they are undergoing nucleophilic addition reaction. Okay, nucleophilic addition reactions are possible. Next question. When acetyl chloride reacts with any amine, what is acetyl chloride? Tell me. CH3C double bond OCl. Acetyl chloride reacts with any of the compound. When acetyl chloride are going to react with any of the compound like amine RNH2, H and Cl are going to eliminate to form CH3, C double bond O, NHR. You know, this reaction is what, children? Acetylation. Remember one thing, acetylation is possible in primary and secondary amine, but it is not possible in tertiary amines because tertiary amine do not contain replaceable hydrogen atoms. Next, question number 37. The ratio of carbon, hydrogen and oxygen in 2-methyl benzoic acid. You only write down. This is benzoic acid and this is 2-methyl. You calculate all the number of carbon, hydrogen and oxygen and make the ratio over here. We'll get the ratio as 4:4:1. Okay, second option. Question number 38. Semi-carbazide is. Semi-carbazide where we are going to use, tell me. Semi-carbazide we are going to use for the condensation reaction NH2. Therefore, the option is what? Third one. Whenever the aldehyde or ketone, any carbonyl compound treated with the semi-carbazide, they are going to produce what, children? Semi-carbazole. With the elimination of water. With the elimination of water, they are going to produce semi-carbazole. Salicylic acid is treated with bromine water in two different ways. One, bromine, question number 39 it is. Question number 39. Salicylic acid is treated with bromine because salicylic acid is what, children? Orthohydroxybenzoic acid. Orthohydroxybenzoic acid, that is a salicylic acid. When salicylic acid reacts with water, bromine in two different way. One they have given bromine water, and the second they have given with respect to bromine in acetic acid. They are asking that which will be the probable answer. When they are treated with bromine in acetic acid, we are going to get the product as ortho and para substituted salicylic acid. But remember here, whenever the ortho and para will be there, para will be major product. Para will be major. That's why we are not going to consider ortho at all, because major product we need to concentrate. Okay. Para will be major product. Further, what they said, this one treatment with bromine water. With bromine water, they are going to produce the white precipitate of 2,4,6-tribromophenol. 2,4,6-tribromophenol. Therefore, the correct option is what, children? Second option. Question number 40. Which of the following acid has smallest dissociation constant? Before going to the option, this is most expected question. Remember here, whenever the acid RCOOH in aqueous medium going to attain equilibrium with carboxylate ion, correct? With what, children? Carboxylate ion. Carboxylate ion. So we can say that whenever we are going to write Ka value, Ka will be what, children? RCOO minus, this will be H3O plus divided by RCOOH. Correct? So here we can say that Ka directly proportional to strength of acid. Ka is directly proportional to strength of acid. That's why we can say that they are asking the question, which of the following acid has the smallest dissociation constant? The question is related with what, children? Question is related with weakest acid. Question is related with what? Weakest acid. Always remember that higher the value of Ka, stronger will be the acid. Smaller is the value of Ka, weaker will be the acid. And another point, this one side, other point we said that based upon negative inductive effect. Based upon negative inductive effect, have you remember, children, what we said? Based upon negative inductive effect, we said that the order of whenever the electron withdrawing group, okay, whenever the electron withdrawing group attached to carboxylic group, carboxylic acid, acidic strength is going to be increases. Acidic strength is going to be what, children? Increases. Acidic strength is going to be increases. So it means that based upon the electron, here in the option, fluoro group, bromo group are there. So high electron withdrawing group is fluoro, than chloro, than bromo, than iodine. So it means that fluorocarboxylic acid will be strong acid. Another point, one more, because two options are there with fluoro. Two options are there with fluoro. Remember one thing, negative inductive effect weakens as the length of carbon chain increases. So it means that in the first option, fluoro group is directly linked to alpha carbon atom. But here, it is linked to beta carbon atom. Okay. gamma carbon atom. So we can say that whenever we are going to take, this will be very close. That's why negative inductive effect will be more effective. This will be strong acid. But the question they are asking what? Weak. That's why both are the strong. No question arises. Question arises between what? This and this. Between this and this. Same point arises over here. Br is linked to alpha carbon atom and this Br is very far away from carboxylic acid. And the question is the smallest dissociation constant. Therefore, the option is what? Third one. Option is what, children? Third one. Lactic acid on oxidation. What? Lactic acid on oxidation with Fenton's reagent. As we said that mixture of hydrogen peroxide and ferrous sulfate, they are called as Fenton's reagent. So it means that whenever the lactic acid CH3, CH, OH, COOH. Okay, this is lactic acid. Lactic acid is optically active. Lactic acid is optically active. When this lactic acid treated with what we said that it is a Fenton's reagent, and as well as it can react with the Tollens reagent to produce what? Pyroic acid. To produce what? Pyroic acid. Pyroic acid. Therefore, which is the option? Third option. Question number 42. On mixing ethyl acetate with the sodium chloride, ethyl acetate CH3, COO, C2H5. This is ethyl acetate. Ethyl acetate with the sodium chloride. Okay, ethyl acetate with the sodium chloride. They are asking that when they undergoes reaction. Remember one thing, whenever we are going to treat ester when treated with halide, that is alkyl halide, Na is replaced by methyl group to get a methyl propanoate. With this, we are going to get again ester. Here we'll get the substituted compound, but the no reaction with respect to this one. We'll write the reagent as it is. No reaction. We'll get what, children? No reaction. Question number 43. What is this? What is the name of this molecule? Acetamide. Okay. We are having how many this one? 1, 2. We'll count once again. Okay. What happened? Okay. When treated with X, they are asking that amide group is converted into primary amine. Amide are converted into primary amine. The best reducing agent is lithium aluminum hydride. Always you need to remember that whenever the amide, I'll take the general equation here just to observe reaction. Amide undergoes reduction, partial reduction. Okay, converted into what we can say RCH2NH2. That is reduction. But when this undergoes Hoffman bromamide reaction, bromination in presence of alkali will produce amine with one carbon atom less. With one carbon atom, what, children? With one carbon atom less. And this reaction is called as Hoffman's bromamide reaction. But conversion of amide into that is primary amine. This is common reduction. Okay, when propanamide undergoes reduction, it is going to produce what? Propanamine. And this is propanamide. Propanamide is converted into propanamine. Next question. Question number 44. Acetone reacts with the Grignard reagent. Okay, as we know very well that formaldehyde with Grignard reagent gives primary alcohol. All aldehyde, any aldehyde with the Grignard reagent will produce secondary alcohol, and the ketone with the Grignard reagent produces tertiary alcohol. Not only ketone, always remember here, first I'll write the reaction, later we'll discuss. CH3, C double bond O CH3. What it is? Acetone. When acetone is treated with water, Grignard reagent RMgX, we are going to get CH3, CCH3, OMGX, and this will be R. On hydrolysis, they are converted into what, children? Tertiary alcohol. They are converted into tertiary alcohol. One thing you need to remember over here, ketone. Just to observe what I am writing here, the additional point, ketone, esters, and acid chloride, acid halide. When treated with Grignard reagent, the product is tertiary alcohol. That's why, as I said earlier, that don't think that okay, for every question we need to write the reaction. Just by based upon the synopsis concept also, without wasting much time, we can go for ticking the correct option. Next one. Which produces ammonia on reacting with the caustic soda? Which produces ammonia on reacting with caustic soda? Okay, we'll write here. Caustic soda means what? Sodium hydroxide. When acetamide heated with caustic soda. Okay. They are going to liberate what, children? Ammonia. They are going to liberate what? Ammonia. So remember here, whenever we are going to add with respect to this one, they are going to liberate ammonia. But that reaction is not possible in case of ethylamine, because ethylamine is already basic in nature. Dimethylamine, it is also basic in nature. Aniline also basic in nature. You are going to add the caustic soda also base. That's why don't expect any product over here, because all these ethylamine, dimethylamine, or aniline, all these three are what, children? They are basic in nature. Their nature is what? Basic. Their nature is basic. That's why we cannot expect any product over there. Okay, that's why we can write the answer for question number 45 as third option, that is acetamide. Acetamide, IUPAC name is what? Ethanamide. Okay, this completes 45 questions, children. Okay, all the best and do well for every this one day test. You need to prepare well. Okay, every day, whichever the test, whichever the topic you are going to write with the good preparation. Okay, once again, congratulate on your theory result. We hope that we'll get the good rank similarly in NEET, JEE and KCT also. Okay, thank you one and all the best for tomorrow's exam. Thank you.